Yesterday's topics?
No, ma'am, no doubt.
No. Okay. So as I told you now, there are certain verifications and all. They are not important. So I'm just skipping them. Okay. If you have your textbook on handy, please open this chapter beta reflection of light. There are certain
Yes,
examples. We'll discuss them.
yes, ma'am.
There are certain problems. We'll discuss them. If you
Ma'am,
have,
it's fine.
yeah, yeah.
Yes, ma'am.
Just wait a minute. Just wait a minute. Okay.
Yes, yes, ma'am.
Visible now?
Yes, ma'am.
Okay. So see that example what is given in your book. A ray of light is incident on a plane mirror as shown in the figure. So what was the figure? This is how the figure was given. So this is the mirror and non-reflecting side. So incident ray and here 40 degrees angle is given. Do you see that?
Yes, yes, ma'am.
Yes.
Yes, ma'am.
So find the angle made by the reflected ray with the mirror. So reflected ray with the mirror. So what is this angle called? The angle between reflected ray and the mirror. Can I call it as glancing angle of reflection?
Yes, ma'am.
Okay. So what was the angle that is given to us in the diagram? This is the incident ray. Incident ray with the mirror. What is this angle? Glancing angle of incidence.
Yes, ma'am.
This is what they have given. Okay. So this is our normal. Now can you tell me what could be this angle beta? Angle of incidence?
50 degree.
50 degrees. How did we know this? Because we know between the mirror and the normal the angle will be 90 degrees, right? So
Yes,
if you
ma'am.
take 40 degrees plus angle of incidence, it must be equal to 90 degrees. Then what
Yes, ma'am.
about angle of incidence? 90 minus 40, 50 degrees.
Yes, ma'am.
So if I assume that this is the reflected ray, angle of incidence is 50, so angle of reflection is also how much? 50 degrees. And we know that here also between normal and mirror the angle is 90 degrees. So what will be this glance along reflection of 90 minus 50? So you'll get 40 degrees. Okay, so this is how we do. But remember directly, if angle of incidence is equals to angle of reflection, then glancing angle of incidence will be equal to glancing angle of reflection.
Ma'am, every time they both will be equal means so GI is always equal to G.
Exactly. Okay, so this is the procedure that we do, but this is the short trick. Directly we can equate, because if angle of incidence is equals to angle of reflection, all the time glancing angle will be what? 90 minus I, 90 minus R. They are same values, I and R.
Yes, ma'am.
So you'll get GI value will be equal to GR. So directly you can say this is 40 degrees. Okay,
Yes, ma'am.
so this is the answer. Any doubt in this numerical part?
No, no doubt.
Okay. Now see the second question what was given. A plane mirror is inclined at 40 degrees to the floor. So this is the floor, and to this floor mirror is kept at certain angle. So this was the mirror, and what was the angle between the mirror and the floor? It was 40 degrees. Okay.
Yes, ma'am.
An incident ray parallel to the floor strikes the mirror. So incident ray is parallel to the floor. So floor is horizontal. So if incident ray has to be parallel, then how must be the incident ray? It also
Vertic.
must
No, no. Yes, ma'am. Sorry. Horizontal only. Yes, ma'am. Horizontal.
okay. So floor is horizontal. So if incident ray is parallel to the floor. In that case, how must be the incident ray? That must be horizontal.
Horizontal.
Okay. So this is your
Yes.
incident ray parallel to the floor. Okay. Strikes the mirror. Okay, fine. It is striking the mirror at this point. And a reflected ray is formed. Okay. So this is the reflected ray. Let us assume. Now, what is the angle of reflection? They're asking you what is R value. Okay.
Yes, ma'am.
So how shall we do this? Observe here, if this is the point of incidence O. At this point of incidence, if you draw a perpendicular, which is making 90 degrees with the mirror. This is your normal n dash, right? Now you have to
Yes,
find out this angle, the normal between reflected ray and the normal. So to find the angle of reflection, what we must know? We must know the angle of incidence, right? Then
yes,
you can
ma'am.
apply I is equals to R concept. So observe here carefully. This is your incident ray, okay, and this is your floor. Both are parallel, right?
Yes,
And
ma'am.
this is how your mirror is kept. So can I use the mathematics principles now? So can I call this mirror as a transversal now?
Yes, ma'am.
Do you remember your maths principles, geometry?
Yes,
Two
ma'am.
lines parallel. This is line M, this is line N, and this is your transversal line L.
Yes, ma'am.
Okay, so this is how they are arranged. Floor is like N line, incident ray is like M line, mirror is like transversal L line. Okay, so what
Yes,
are
ma'am.
the properties of the transversal? Opposite angles will be equal.
Equal. Yes, ma'am.
Opposite angles are equal. Okay, so here we are given angle of 40 degrees. So opposite angle will also be what? 40
Got
degrees. Okay, so what
GI
is, yeah, so I can say now here, so this angle is 40 degrees. Okay, but what is this 40 degrees angle here? Incident ray mirror. 40 degrees is the angle between incident ray and mirror, that is glancing of angle of incidence is 40.
Yes, ma'am.
So glancing angle of reflection will also be what?
Got
40. Now what about angle of reflection? Total angle is 90. R
15.
plus GR. Total is 90. So what about R now? 90 minus 40. So how much will you get here? 50.
50.
So R value is how much? 50 degrees. That is our answer. Therefore angle of reflection is 50 degrees.
Yes, ma'am.
Any doubt in this?
No doubt.
Clear. Okay. Now we'll see the concepts now. Okay, so the next concepts. Yesterday, are you clear with what is reflection?
Yes, ma'am.
Okay, now we'll see types of reflection. Okay,
Yes, ma'am.
so do you have any idea about this types of reflection?
Yes, ma'am. Regular reflection and irregular.
Yeah, what happens in regular and what happens in irregular?
Ma'am means uh, in regular reflection it occurs in on smooth surfaces, ma'am, like on plane mirrors,
Mm,
on highly polished surfaces like that, ma'am.
mm.
But here it occurs on. It does not remain. It will be uneven, ma'am. The surface remains uneven.
Okay, just wait a moment, Gautam. So if you take the mirror in horizontal position, then the plane in which incident ray, normal line and reflected ray, where they are lying, that will be in vertical position. That means what will be the angle in 90 degrees. One is horizontal, the other plane is vertical. That means between them the gap will be 90 degrees. So incident ray, normal, reflected ray, where they are lying, this plane will be perpendicular to the mirror. Is this point clear? Any doubt in this?
Clear, ma'am. Yes, ma'am.
Clear. Okay. Now we will see formation of images in plane mirror and by taking two different objects. What are the two different objects, Gautam? Depending on the size, how do we classify the objects?
Point object and extended object.
Point object and extended object. So before saying the formation of image in a plane mirror, we do consider certain things. I tell you those considerations. Okay, how we have to construct an image, how we have to consider the incident rays. Let it be any mirror, Gautam. So first point, considerations for plane mirror image construction or image formation. What do we consider is, first consideration is incident ray along the normal. See, you can consider incident rays at any point on the mirror, right? But we just consider one incident ray along the normal. Okay, then where will be the reflected ray, Gautam?
Along the north.
Very good. Reflected ray also will be along the normal. Why is it so? When incident ray is lying on the normal, there is no gap between incident ray and normal. In that case, angle of incidence 0, then angle of
Yes.
reflection is also 0.
See.
Now second ray, how do we consider? You can consider incident ray in any direction. I'm just saying incident ray in any other direction. Okay. Then how you
Okay.
have to consider the reflected ray? You just have to measure the angle of incidence. You have to take the same as the angle of reflection, and in that direction you have to consider the reflected ray. Okay, so
Yes.
reflected ray is constructed with angle r from the normal.
Yes, ma'am.
Okay, how do you know this angle r? If incident ray is 30 degrees, then reflected angle is also 30 degrees. Accordingly, you have to construct. And
Yes,
third point, what you have to do is,
ma'am.
this is first reflected ray RR1. This will be
This
second
will be
reflected ray RR2. So RR1, that is reflected ray 1, RR2 reflected ray 2. What you have to do is, you have to meet them. You have to meet them at a point. That means you have to extend them backside, then they will meet at a point. So that point will be the image.
but that is virtually.
Yeah, that will be virtual image, exactly. if you
Yes.
if you get a point by making them meet by extending them backwards, then it will be a virtual image. Okay, of
Yes, ma'am.
course plane mirrors all the time form the virtual image. Clear with these considerations?
Yes, ma'am.
Okay, now we will construct the image. So first we'll take point object and we take a plane mirror, and we'll try to get image for this point object. Okay, so how will be the plane mirror? This is how the plane mirror, right?
Yes,
Now
ma'am.
I just consider this as the NRS, non-reflecting side, and this is RS, reflecting side. Now I just assume an imaginary point at center of the mirror O. I just take it as the point of incidence. Okay, now if I construct one perpendicular along this point of incidence, what do we call it? We call
Normal.
it as normal. Okay, this is N dash. Now what is the first consideration that I told you to construct the image? First incident ray along the normal. So
Yes.
along the normal, one incident ray. This is first incident ray.
Yes, ma'am.
Now where will be the reflected ray after touching this point of incidence? It will come back in the same direction.
Yes, ma'am.
So this is first reflected ray. Any doubt in this?
No, no doubt, ma'am.
Okay. Now second incident ray, how should I consider? Making certain angle. So I just consider an incident ray like this falling at the point of incidence. Now this is my second incident ray. This is my angle of incidence I2, because angle of incidence I1 is 0 and R1 is also 0.
Yes, ma'am.
Okay. Now what I have to do? I just have to measure this angle. The same angle I2 I have to keep on the other side. With that same angle I have to construct a reflected ray.
Yes, ma'am.
Okay. So this is my reflected ray 2, and here angle of reflection is R2. So
Yes.
R2 value is equals to I2. For suppose if you take 30 degrees here, here also 30 degrees. Okay.
Yes.
Now, so where are my reflected rays now? Just observe. This is my first reflected ray. This is my second reflected ray. So
Yes,
to
ma'am.
get the image, I have to extend them. Now you just try to extend them in forward direction. This is first reflected ray. This is second reflected. Are they meeting in the forward direction?
Never meet, ma'am.
Never meet, because the rays are diverging. So do you
Yes,
get a
ma'am.
real image now if they are not meeting actually?
No, ma'am.
No. Okay. Mm, this is angle of incidence I2. Okay, where did we consider the object first of all? We haven't considered the object. Just wait a minute, I'll redraw the diagram. We haven't considered the object, no, Gautam. You didn't tell me. Okay, so this is the mirror. So point of incidence O, and this is the normal n dash, this is mirror m dash, nrs, this is rs. So one in, let me take, where do we take the object? Let me take object here itself. Okay,
Yes, ma'am.
okay, object. Okay, now so one incident ray, first reflected ray. Now
Yes,
from the object I have to make another incident ray which is not along the normal. So I'll just take, where do we take? I'll just take here. Okay, this is my second incident ray. Now this second incident ray is striking the mirror at which point? At this point. So this is second point of incidence. Okay, now at this point of incidence, if I draw a perpendicular line, this is normal 2, this is normal 1. Okay, now this is angle of incidence I. With the same angle I have to construct a reflected ray. This is second reflected ray, angle of reflection R. Any doubt in this?
no, no doubt, ma'am.
Okay, we are considering two different directions for incident rays. So we'll get 2 point of incidences. Okay, and two
No, but
normals.
it's one right, ma'am. Only one object.
For the one object, for the same object. Yesterday I told you, now if you take an object, the incident rays go in all the directions. So
Yes,
we
ma'am.
are just considering only two rays.
Yes, ma'am.
Okay, now where are the reflected rays? So this is first reflected ray, this is second reflected ray. Two rays are enough for getting the image point. So if you extend in forward direction, they are not meeting. So extend them in backward direction. So this is second ray extended, this is first ray extended. Where are they meeting? They are meeting at this point. So this is the point of image.
Yes, ma'am.
Got this point?
Yes, ma'am.
Any doubt in this construction?
No doubt.
Okay. Now we will take extended object. Okay.
Yes, ma'am.
How do we consider extended object? What is the way that we represent it?
Upward arm.
Okay. So extended object, and we take it for plane mirror. This is plane mirror m dash. Okay. So I'll just consider a line for keeping an object. Okay.
Yes, ma'am.
This is a line for placing an object. Generally it will be called principal axis, but I'll tell you the terminology later. Okay. Now, so this is my object A and B. Head is taken as A, tail is taken as B. Now, if you take B point, Gautam, where is the B point? B point is on the line for, it's on the same line, right? So
Yes, ma'am.
if I consider incident ray from B point, this will be the reflected ray. Okay.
Yes, ma'am.
Now I'll consider one more incident ray from B point. This is first incident ray, second incident ray. So this will be the normal. This is the angle of incidence, and this will be the reflected ray, and this is the angle of reflection. So to
Yes,
know the position of B point, I'm just taking two reflected rays, first reflected ray, second reflected ray. So if I extend them in forward direction, they don't meet. So I have to extend them in backward direction. So backward direction extension, first one, backward direction extension,
second.
second one. Okay, so where are they meeting? They are meeting at this point. So this is your B dash. So
Yes, ma'am.
from B point of the object, you are trying to construct an image. Just like
Yes,
point object. One is along the normal, the other is with certain angle. Okay.
yes, ma'am.
Now we should know where is the top of the object also. So we just follow the same procedure. From the top, you take one Sida. Okay, so this is your first incident ray. Reflected ray is also in the same direction. Now
Yes,
you
ma'am.
take with some other angle. Now where do I take? I just extend the mirror. So this is my second incident ray. This is point of incidence O, angle of incidence I. So it will reflect. This is angle of reflection R. So
Yes,
first reflected ray, sorry, second reflected ray and first reflected ray. So I have to extend them. So if you extend, where do you get? This is first reflected ray extension. This is second reflected ray extension. So they are meeting at this point. So this will be your A dash.
Yes, ma'am.
Now if you take any point image construction between A and B, anyhow you'll get between A dash and B dash. No, so no need to take. You need to take the top point and you need to take the bottom point. Between, if you try to construct for any point, it will be lying between A dash and B dash only. So no need to do for that. Directly you can take here. Okay, A dash, B dash.
Yes, ma'am.
Got this point? Now see this diagram. A is at the top, image A dash is at the top. B is at the bottom, image B dash is at the bottom. So are we getting the erect image or inverted image?
Correct image, ma'am.
Erect image. And if you see height of the object, height of the image, is it same or different?
Same.
Same. Okay. Now this is your mirror. From mirror to the object, whatever the distance that is present, that is called object distance U.
Image distance.
Okay. Now between the mirror and the image, that distance is called what? Image distance, and it is denoted by the letter what? V. Okay.
V.
So
Okay.
yeah, V. U is for object distance, V is for image distance.
Yes, ma'am.
Now object distance, image distance, are they equal or different here?
Equal. U
E
is equal to.
Yeah, U is equals to V. So there are certain characteristics of the image which is formed in a plane mirror. We will see it now one by one. Diagrammatically, are you clear?
Yes, ma'am.
Okay. So next topic is characteristics of image formed in a plane mirror. So first point, object distance is equal to what?
Image distance.
Image distance. Object
Ma'am,
distance, yeah, Mira.
ma'am, plane mirror always forms a virtual.
Always forms a virtual image, yes.
Okay, ma'am.
All the time, because you are getting the intersection after extending them backward, no?
Yes, yes, ma'am.
Okay,
In
so
forward, they don't meet.
yeah, they don't meet, because if you extend in forward, they still, become more divergent.
Yes, ma'am.
So U is equals to V, first point. And second thing, object height is equal to what? Image height. For suppose if you stand in front of the plane mirror, how much height is there for you really? The same height will be shown even in the mirror. Okay. So height
Yes,
of the object HO, height of the image HI. HO will be equal to what? HI.
yes, ma'am.
And third important point, how is the image? Image is erect. Okay. That means if you take object AB, image will be A dash B dash.
Yes,
Okay.
ma'am.
So erect. And what else? It will be same height, that is done, at same distance, that is done. Mm,
Virtual image.
and it will be virtual image, yes, because it is obtained by extending the reflected rays backward. Okay.
Yes,
And
ma'am.
next important point, image will be laterally inverted.
Yes, ma'am. Means left appearing, right and right appearing.
Yeah, so laterally inverted in the sense sidewise reverse.
Yes, ma'am.
Sidewise image will be reversed. That means left becomes right, right becomes left. So for suppose if I take object point of view and if I take image point of view, object point of view right side becomes image point of view left side.
Yes, ma'am.
Object point of view left side becomes image point of view right side. So that is the meaning of laterally inversion. For suppose if you stand in front of the mirror, for you it's right hand. If you go to image direction, it will be in the left side. So
Yes, ma'am.
right side of the object becomes left side of the image, and left side of the object appears like right side of the image. Okay, so sidewise reversing is called what? Lateral inversion.
Yes, ma'am.
Okay, and this is important for objective point of view. Like they will ask you, write the lateral inverted images of S letter, P letter, Q letter, M letter. They'll ask you like that. You need to practice this. Okay,
Okay, ma'am.
like I'll just give you some letters now. For suppose, yeah, if I take B, there is a mirror here. So how will B appear in the image? Like this.
Yes, ma'am.
Because this is the right side, so here it becomes left side.
Yes, ma'am.
Okay, for suppose if I take Q like this. Now this is the right side. So how will it be in the mirror? This is how it is. It becomes left side.
Yes, ma'am.
Okay, for suppose if I take M, how will it be in the mirror? Same M only. Because
Yes,
left
ma'am.
right it's same, no?
Ma'am, O also.
O also it will be same. Okay. For suppose if I take P, how will it be in the mirror? This is the
Like
right side, so left side. So if you see, top and bottom are remaining the same. Only left is becoming right and right is becoming left. That is the only difference.
yes, ma'am.
Okay, any other doubt? For suppose if I take G letter, how will it be appearing in the image? This is how it appears. Okay,
Yes, ma'am.
because this is the left part, so it appears in right part. And this one is on the right side, so it will appear on left side.
Yes, ma'am.
Okay, so this is important, Gautam. This is
Okay.
important. Okay, and have you seen the ambulance vehicle?
Yes, ma'am.
Yeah, so how will be the letters of ambulance written on that?
It will be inverted.
Inverted, laterally inverted. Okay,
Yes, ma'am.
so the word ambulance is written in reverse manner. Why is it so? It's because of the same reason. Okay, so imagine you are riding a vehicle here and there is an ambulance which is coming behind to you. Okay, so how do you see the vehicles coming back after you? You will see in your rear view mirror, right?
Yes, ma'am.
So for the bike, for the car, there will be side mirrors. Side mirrors are called rear view mirrors. Side mirror is nothing but rear view mirror. So you are seeing the back of the vehicle in the mirror. So in the mirror, what happens? Left appears right, right appears left.
Yes, ma'am.
So that's the reason they will write ulta here. If they write correct, what happens? It will appear in reverse to you. So that is
Yes.
why they themselves first write in reverse.
For us, it will appear correctly.
Yeah, for us it will appear correctly. Okay. So when
Yes,
you
ma'am.
take ambulance, okay, so how it will be written actually? Its mirror image will be written. So first they will write E and then C and then N and then A and then L. U is as it is. This is V. This is M and this is A. So this is how they will write. So this is written on vehicle and this is how we will see.
Yes, ma'am.
Okay, so if they already write it ulta, ulta becomes again ulta and we will see it correctly.
Yes, ma'am.
Okay, clear?
Yes, ma'am.
Yeah. And what are the uses of plane mirror? You have any idea?
Ma'am, it is used in kaleidoscope.
Used in kaleidoscope. Kaleidoscope is a toy which is for visual happiness. That's it. Okay, different colors, different number of images. It's for visual treat. Okay.
Yes, ma'am. It is used to see ourselves also.
Yeah,
In
beta. Yeah, beta. The uses of plane mirror. So first thing we use it in our daily life.
yes, ma'am.
Okay, you want to go to school, you have to get ready in front of the mirror. Okay, and
Yes, ma'am.
also in jewelry shops. So why do they use in jewelry shops? Because the owner is here and the customers are here. If they are doing something here, the owner can see in mirror.
Yes, yes,
Okay,
ma'am.
though he don't see you directly, what you are doing, he can see it in the mirror. Okay,
Yes,
so jewelry shops, all valuable shops, the entire shop will be covered with mirrors. This is the reason, because reflection takes place and we can see indirectly what they are doing. Okay,
yes, ma'am.
okay, and in
Like
road,
any test like that.
yeah, theft and all like that. Okay, road turns also, what do they do? Steep roads will be there. Okay, if there is a curve, so what do they do here? They'll keep the mirror.
Yes, ma'am.
Okay, so this mirror captures the one coming from forward direction, also from downward direction. So for
Yes.
suppose if you are coming in this direction, you can see who is coming in the opposite direction. The same way the person who is coming from upward direction, he can see the one who is coming in downward direction, because the mirror is at the bend point, so it can capture from both the directions,
Yes, ma'am.
so that we will get a clarity who is coming in opposite direction and we can take care of ourselves. Okay, so road
Yes, ma'am.
turns also we will use the mirrors. And in periscopes, in kaleidoscopes. Okay, and next one in solar cookers. So we will see now one by one, like how it is used in periscopes, how it is used in solar cookers, how it is used in kaleidoscopes. So like if you take periscope, how will it be better? How will be the periscope?
Ma'am,
Hmm?
in Z shape.
It is in Z shape. Okay.
Yes, ma'am.
First we'll discuss about periscope. Okay. So periscope is a tube which is bent in the form of a Z shape. Okay.
Yes, ma'am.
And what do they do here? They keep two mirrors. This is first mirror, this is second mirror. Mirror 1, mirror 2. And
There'll be a
yeah, how mirrors are kept? They are kept at 45 degrees angle. Okay.
yes, ma'am.
Okay, and here non-reflecting side. Here non-reflecting side. Back side will be the non-reflecting side. And when
Yes,
incident rays fall on this, what happens? It makes an angle of 45 degrees. This will be angle of incidence. Now what will be the angle of reflection here?
40.
45 degrees. Now this is the angle of reflection for the first mirror. The angle of reflection of first mirror becomes what? Angle of incidence for second mirror, right?
Yes, yes,
So
ma'am.
angle of reflection of first mirror is nothing but angle of incidence of second mirror. So
R becomes I here, ma'am.
yeah, I2 is 45 now. So R2 is also what? R2
40.
is also 45. So as you are giving a desired position of mirrors inside the periscope, we are making sure that the angle of incidence, angle of reflection all the time remain 45 degrees, 45 degrees. Okay.
Yes, ma'am.
Now, so what is the use of this? For suppose, let it
In
be you here,
military.
Gautam. Okay. So if I
Yes.
stand in front of you, I can see you directly. But what is the other possibility that I don't stand directly in front of to you, but I be somewhere at down position, but still I can see you. In that case, we will be using periscope.
Yes, ma'am.
Okay, the person will not stand in front of you directly, but still he can observe with the only means of periscope.
Yes, ma'am.
Okay, so this will be used by what? It will be used by soldiers.
Yes,
So
ma'am. To
soldiers
see
also,
the
yeah. So what do they do? So this is the war field. Maybe some enemies are attacking here. So when the enemies see what happens, they don't find any soldiers here. But where will be soldiers? Soldiers will be hidden and using the periscope. Okay. So they
yes,
will
ma'am.
be observing the people coming or not with the help of periscope. If
Ma'am, if an
yeah,
submarine also you.
yeah, submarines are also the same case. Like because submarine is traveling inside the ocean. Like
Yes,
if
ma'am.
any other ships are coming on the surface of the ocean, if there is any possibility for collision and all, how do they observe? With the help of the periscope. The same
Yes,
thing.
ma'am.
Okay, so this is how it is used by soldiers and also used in submarines. Clear with this?
Yes, ma'am.
This is the use of periscope. And in periscope, what kind of mirrors are we using here? M1, M2. These mirrors are plane mirrors.
Yeah, ma'am.
So,
Plain.
so this is the use of plane mirror, and this periscope is having the other uses, that is in warfield and in submarines. Okay.
Yes, ma'am.
Now next one is what? Next one is kaleidoscope. So in kaleidoscope, what do we do is we just take a cylindrical structure bent at three places. Generally cylinder will be like this. What do? We just take bent form. That means one, two, three. Bent at three places. First point, second point, third point. So that the cylinder comes in the form of a triangle. Okay.
Yes, ma'am.
This is at back side. This is at back side. Okay. So we are not taking a circular cylinder. If you take normal cylinder, the base and the top will be in circle shape. But if you take normal kaleidoscope, it's a cylinder tube, but the base and the top will be in triangle shape.
Yes, ma'am.
Okay, that's the difference. It is also a long cylindrical tube, but the base and the top will be what? It will be in triangle shape. Okay. Now,
Yes, ma'am.
so three sides will be there now. First side, second side, third side throughout the tube. So what are these three sides are made up of? They are made up of plane mirrors. So this is
Yes.
how we are using plane mirrors in kaleidoscope. Okay.
Yes, ma'am.
And the other side, if I take this is at the top position, this side, this triangle is at bottom position. At the bottom also we use one mirror.
Yes, ma'am.
Okay, so top position we keep an eye to observe what will be happening. Okay, so this is for observing. One end
Yes,
will be used for observation, the other end will be covered, it will be closed with again one more mirror. Okay, and how do we use this? For suppose if you see, no, if you keep any, some colored particles, or maybe yourself, if you want to see yourself, what happens, you can see different pictures of yourself, more number of images, because more number of reflections takes place, because all the sides it is covered with mirrors, no.
yes, yes,
For
ma'am.
object, first you'll get one image, that image will get another image. So like that, multiple images will be formed in kaleidoscope. Okay,
Yes,
so
ma'am.
instead of seeing ourselves, if you keep some colored particles, no, so different colors undergoes multiple reflections, and that looks beautifully. Okay, this is actually for visual treat. Seeing it, we will feel happy.
Yes, ma'am.
Okay, so that's the use of kaleidoscope. And in this kaleidoscope also, what are we using? We are using the plane mirrors.
Yes, ma'am.
And
Ma'am,
we
but ma'am, in
hmm,
periscope, if the mirrors, there's one disadvantage. It can get fog and
yeah, not only in periscope, even in kaleidoscope also, if the mirrors get any dust particles on them, or if it in rainy season, or if it is in winter season, if some fog is collected on them, then they won't give proper reflection and the image will be blurred.
blood. Yes, ma'am.
Okay, but kaleidoscope is for playing purpose, no, so we don't bother much. But when you take periscope, we are using it in real world, like soldiers are using it, submarines we are using it. So when you are applying it practically, then we need to be little careful. All the time we need to check the quality of the mirror. And if you have to travel in some winter places or foggy places, you just have to keep extra set of mirrors. You have to replace them all the time.
Yes, ma'am.
Okay, so that, yes, that is a disadvantage. Yes. Now third one is solar cookers. So what do we do in solar cookers? What is the purpose of cooker beta? To cook the food, right?
Yes, ma'am.
Now solar in the sense what, using sun rays.
Yes, ma'am.
Okay, I think you have studied the ray diagram construction for concave mirrors, all those things, right?
Yes, ma'am.
Yeah, the same thing we will do here. So we will just take a box, and this is the lid of the box. You just have to consider open position. Okay, this is the one lid which is open, and this is the box where we keep a container here. Okay, so in this container we keep the food particles which will be cooked. So we have to supply heat energy, then only food will be prepared, right? So how are we supplying the heat energy here? Sun rays will be made to fall on this lid open part. This lid open part is actually covered with mirror. It will be covered with the plain mirror.
Yes, ma'am.
Okay, so what mirror will do? It will reflect the rays. So all those rays will be reflected, and we just keep the lid in such a position that all the reflected rays will fall into the container. This is the
Yes,
bowl. We just make sure that all the reflected rays fall into the bowl. Then what happens? More amount of rays entering, sun rays entering, that means more amount of heat energy supplied, and the food will be prepared.
yes, ma'am.
Lid will not be perfectly erect, it will be tilted, it will be kept at a certain angle, so that
Yes, ma'am.
maximum of the sun rays will be reflected into the bowl. Okay,
Yes,
is this point clear?
yes,
So
ma'am.
this is all about uses of plane mirrors. Any doubt so far?
No, ma'am.
Okay. Now we'll see another concept, images formed by inclined mirrors. You just need to understand only the formula here.
Yes, ma'am.
Inclined mirrors means what? The mirrors which are not parallel, they are intersecting and they are at certain angle, maybe 30 degrees angle, 40 degrees angle, like that. Okay.
Yes, ma'am.
Now here you have to consider two cases. So case 1, let this be mirror 1, let this be mirror 2. Okay, the angle between them is taken as theta. What is theta here? This is the angle between first mirror and second mirror. So what are the two cases? First case you have to take 360 by theta. Second case also you have to take 360 by theta. If 360 by theta is odd, one case. If it is even, other case. Okay.
Yes, ma'am.
So if it is even and if you keep any object here, okay, in that case how many number of images will be formed? Number of images is equal to 360 by theta minus 1. That means if theta is 30 degrees even angle, then you have to take 360 by 30 minus 1.
Okay, ma'am.
60
Then it is
degree,
yes,
yeah, 60 degrees even angle. So you have to, how many images will be formed? 360 by 60 minus 1.
5.
Okay, so if 360 by theta is an even number, then you have to take 360 by theta minus 1. That will be the number of images.
Yes, ma'am.
If this is odd value, then again here you will get two cases. First case symmetrical position, second case asymmetrical position. Symmetrical position, asymmetrical position. Symmetrical in the sense this is mirror 1, this is mirror 2, angle between them is theta, right?
Yes, ma'am.
Now where do we keep the object? We keep the object between both the mirrors, in between mirrors. So
Yes,
if you take this object position and if you construct a line, so this object is at angle 1 from mirror 1, angle 2 from mirror 2, right?
yes,
If
ma'am.
these angles are equal, then it is at symmetrical position.
Yes, ma'am.
That means in mathematics language it must be a angular bisector.
Yes, ma'am. Angular reversal.
Yeah, if both the sides angles are equal, that means this side angle is half of theta, this side also angle is half of theta.
Yes, ma'am.
Then symmetrical position. What is
Yes, ma'am.
asymmetrical position? This is mirror 1, this is mirror 2, total angle is theta. Now if you take an object here, position, this angle is not equal to theta by 2, this angle is not equal to theta by 2, some different angles. Let this be angle 1, this be angle 2, and these angles are not equal. Then in that
Yes,
case at symmetrical position.
yes, ma'am.
Okay, so if it is symmetrical, then what will be the number of, n is a symbol for number of images beta, so this will be equal to 360 by theta minus 1. If it is asymmetrical, number of images is equals to 360 by theta.
Okay, ma'am.
So you just need to remember only two formulas. When two mirrors are inclined at certain angle theta, then first you have to find 360 by theta value, whether it is odd or whether it is even. If
Yes,
it
ma'am.
is even, number of images is 360 by theta minus 1. If it is odd, symmetrical case also formula is 360 by theta minus 1. Only
Ma'am,
in,
how that is it symmetrical or asymmetrical?
for suppose, just take this diagram, okay? This is mirror 1, this is mirror 2. The total angle between mirrors M1, M2 angle is given as 60 degrees, okay?
Yes,
Now
ma'am.
on this dotted line there is an object, okay? Point object. Now it was at 30 degrees from mirror 1. Now how do we decide whether it is symmetrical or asymmetrical? What is the total angle between mirrors?
60, ma'am.
60
Means
degrees.
they will give it right.
Yeah, that side also 30, this side also 30.
Yes, ma'am.
That means object is at equidistant position from mirror 1, also from mirror 2.
Right. Yes,
So
ma'am.
that's the meaning of symmetrical. If
Yes,
you
ma'am.
take from mirror 1 also same position, mirror 2 also same position, then object is symmetrical.
Yes, ma'am.
For suppose total angle is given as 60, this is mirror 1, this is mirror 2, this is the position of object, and object is at 40 degrees angle here. Then from
Uh,
mirror 2 it will be at 20 degrees. Now are these equal?
360 by 2 only theta, ma'am.
Yeah. So if you take object from first mirror, it is at farther distance. It is close to second mirror. That means it is not at equidistant position.
Yes, ma'am.
So this is your symmetrical, yes. This is your asymmetrical, yes.
Yes, ma'am.
Getting my point?
Yes, ma'am.
So you just need to remember only two formulas: 360 by theta minus 1, 360 by theta minus 1. When if 360 by theta value is even, odd also but symmetrical. In both the cases it is 360 by theta minus 1.
Yes, ma'am.
360 by theta odd and asymmetrical, then only 360 by theta.
Yes, ma'am.
Clear?
Yes, ma'am.
Okay. Now you just need to tell me the formulas once again, because based on this maybe you will get some numericals. So tell me, how will you find the number of images n? Number of images n. It will be equal to 360 by theta minus 1. When if 360 by theta value is even and 360 by theta value is odd and symmetrical. Clear?
Yes, ma'am.
Now n number of images is only 360 by theta. When if 360 by theta value is odd and object is at different positions, that means
Asymmetric.
asymmetrical position. Fine.
Yes, ma'am.
Now for suppose you calculated the value, you got the number of images as 5.4, you got in some decimals. Then how will you say, ma'am, number of images can't be 5.4? No, you can say number of images has some definite number, 1 image, 2 image, 10 images, like that. But how
Fine,
will you
ma'am.
say 0.4? You can't say that, right? So in
Yes,
that
ma'am.
cases, this is integer part and this is decimal part.
Yes, ma'am.
So if you get any decimal numbers, this decimal part is not considered for number of images.
Only 5 should come.
Only 5 should come. For suppose they will tell you 6.5. Number of images is 6.
Yes,
Decimal
ma'am.
point is ignored. Okay.
Yes, ma'am.
Okay. So is this clear to you?
Yes, ma'am.
Okay.
Just 1 minute. Just 1 minute.
Yeah.
Yes, ma'am.
Yeah.
Ma'am, if it is asymmetrical, then 360 by theta, right?
Yes. Odd value and asymmetrical.
Ah, yes, ma'am.
First you have to find this 360 by theta value. First you have to
Yes,
confirm whether it is odd or even. If it is odd and asymmetrical, then 360 by theta.
yes, ma'am.
Odd, symmetrical, even, then in both the cases 360 by theta minus 1.
Yes, ma'am.
Any other doubt?
No, no doubt, ma'am.
Okay. So once open your textbook, there are two problems. We will solve them.
Yes, ma'am.
So there is one question. Two men are standing in front of a plane mirror. Did you find that?
Yes, yes, ma'am. Yes.
So here is the first person A, second person B. Two persons are standing in front of the plane mirror. So when man A looks into the mirror, how far away from him will man B seen to be? అంటే ఏ పర్సన్ మిర్రర్లోకి చూసినప్పుడు బి ఎంత దూరంలో కనిపిస్తాడు? దట్స్ ద మీనింగ్ ఆఫ్ క్వశ్చన్.
Yes, ma'am.
A is observing into the mirror. Okay. So
Yes,
both
ma'am.
persons are standing in front of the mirror. So he will see A, also he will see B, right?
Yes,
But
ma'am.
the question is how far from A B image is.
Yes, ma'am.
This is A dash, let it be B dash. The question is the distance between B dash and A.
Yes, ma'am.
Okay. So in the question it was given distance. This is 2 meters and this is 12 meters. Okay.
Yes, ma'am.
Now let me take the diagram. This is the mirror. So object A, that means person A. Here object distance is how much? U value is 2 meters. So what will be the image distance here? That is also 2 meters. Can I take it as A dash?
Yes, ma'am.
Now, so from A, B position is at how much distance? 12 meters. So from mirror to B, what is the distance? Object distance is 14 meters, right?
Yes, yes, ma'am.
So from the mirror, where will be B dash point? 14 meters, because all the time object distance will be equal to image distance. Okay. So
Yes, ma'am.
this is 2 meters already. So between A dash and B dash, how much distance will be there? 12 meters. Any
12
doubt
meters.
in this?
No doubt.
Now what is the question? Between B dash, what is the distance? 14 meters, and extra here 2 meters.
Yes, ma'am.
So distance between image of man B and man A. What is the distance? 14 plus 2, it is 16 meters.
Yes, ma'am.
Any doubt in this?
No
Even
doubt.
if there is a small doubt, Gautam, let me know, because all numerical part is important.
Yes, ma'am. No doubt.
Okay. Now see the second question that is given in your book. So a man looked into a plane mirror and saw the clock as shown alongside. So he saw the image in the plane mirror, right?
Yes,
So
ma'am.
the diagram that is shown here, it's actually what? It's actually the mirror image.
It's virtual image. Yes, ma'am.
It's actually mirror image.
Yes, ma'am. Mirror image.
What was the time then? So if you want to decide the time, will you see the actual clock or the mirror one?
Actual clock.
Actual clock. So how do we decide them? First we have to find the actual clock time. Okay, so this is
Yes,
the
ma'am.
time in the mirror. So how will be the time in mirror? Left becomes right, right becomes left. So
Yes,
what
ma'am.
we have to do now, we have to take the actual clock. Okay, now if you see the small hand, it is to the right side here. So where do we keep here? We keep it on left side.
Left.
Now
Yes, ma'am.
bigger hand, where is it? It is on the left side. Left side, 1 2, second point. So we keep it on the right side, 1 2. Here we keep it. Getting my point?
Yes, ma'am.
Any doubt in this, how to take?
Ma'am, can you explain this one?
Okay, so this is the clock in mirror, right? This is how they have shown. This is the small finger in the clock, this is the bigger finger in the clock, right?
Yes, ma'am.
Both of them are on which side? They are on
Right.
the right side. But in reality, where they will be? Right,
Left side.
left side. Why is it so? Because in the mirror we will have lateral inversion, right? Left
Yes, ma'am.
becomes right, right becomes left. So in the
Yes.
mirror, if you are seeing on the right side, in reality it will be on the left side.
Yes, ma'am.
Okay, so let me take the clock. This is 6, this is 3, this is 9, this is 12. Okay,
Yes, ma'am.
now this is 4, 5, 7, 8. Now in the mirror, where is the small hand? 6, 3, 4, 5. It is to the right side of 6, right?
Yes, ma'am. Right side of 6. Yes.
But in reality, where it will be? It will be left side of 6.
Yes, ma'am.
So I'll
Means on
just, yeah,
between.
I'll just take it here. Fine.
Yes, ma'am.
Now, where is the bigger hand? It is to the right side.
All right.
Right
Yes, ma'am.
side. So where we have to take? We have to take it on left side. Got my
Yes.
point? So right
Yes.
side, 1, 2, second position below. So left side, 1, 2, second position below.
Yes, ma'am.
Got my point?
Yes, ma'am.
This is your small hand, this is your bigger hand. Now what is the actual time? This is at 6 position, this is at 40. So this is 6:40 position.
Yes, ma'am.
Clear?
Yes, ma'am.
Any doubt?
No, no doubt, ma'am.
If you are not clear with this clock one, I'll explain once again
Ma'am, can you explain same question but in with different number?
with a different time. Okay, we will do it. Wait a minute. Okay, tell me which time you want the mirror image.
The mirror 315. No, no. Yes, ma'am. 315.
3:15. Okay. 12, 3, 6, 9. Okay. One,
Yes, ma'am.
2, 3, 4, 5, 7, 8, 10, 11. Okay, 3:15. So this is at 3. 3:15 means small hand, bigger hand, both will you be on the same side, no?
Then okay, ma'am. Then 350, ma'am. 350.
3:50. Okay, so 40, 50. Okay, this is
Yes,
bigger hand, this is small hand, 3:50. Okay, so
yes,
if
ma'am.
this is the mirror image, how will be the actual image? We have to take lateral inversion. For finding mirror image also lateral inversion, for finding the actual image also lateral inversion.
Yes, ma'am.
1, 2, 4, 5, 7, 8, 10, 11. Okay. Now see, first we will see the small hand part. Where is the small hand? Right side in the mirror image. So what we have to do now? Left side in the actual image. Is this point clear?
Yes, ma'am. 9.
Small
Yes, ma'am.
small handle right side in the mirror. So it will be left side in the actual one.
Yes, ma'am.
Actual image. So this is small. Done. Now. So bigger one, it is on the left side. So where we have to take this now?
On 2.
On right side. So
Yes, ma'am. On
right
right.
side, at which point will you take? See, from here at first point we will see it. So from here at first point we have to see it. So this is how it will be.
9, 10. Yes, ma'am.
Got my point?
Yes,
So
ma'am.
what
Understood,
will
ma'am.
be the time now? It will be 9:10.
Yes, ma'am.
Clear?
Yes, ma'am.
Any other
Understood.
doubts?
No, ma'am. Understood.
Okay. So this is what for today. I have extended the class. Sorry, because I just want to complete the topic. Okay.
Okay, okay, ma'am.
Tomorrow, which topic you told me to start? Force, right?
Ma'am, I will just message you.
Your papa talk to me. Force in the sense what? Loss of motion.
Yes, ma'am.
Loss of motion chapter. I think friction was already explained. So you want me to repeat the same?
No need, ma'am. I will just go through it.
I'll go with the force. Friction, you just go through it. I'll go
Yes,
with the force. Okay.
yes, ma'am.
Interconnected blocks, A and B connected, spring force, tension force, difference are there. So I'll go with the force topic. Okay.
Okay, ma'am.
Loss of motion and friction.
Yes, ma'am.
Okay. So tomorrow I'll start loss of motion. Okay.
Yes, ma'am.
Bye, Vita.
Bye, ma'am. Thank you, ma'am.